Hello, Chemistry 11 Honors kids. Hope you're doing well. This is Mr. Chan, and this is the video that I'm going to be talking about just to summarize some of the things that you should have done for the atomic theory review. Now, I'm just going to share a screen, and let's have here. Okay, let's share a screen. Okay, now you were given this particular assignment, and for those of you that weren't there, so what I'm going to ask you to do is when you are doing the Dalton, Thompson, Rutherford, okay, hopefully you got the information about how they were different, but also how they were similar. Now, a couple of things I wanted to talk about was the significance of the gold foil and the Millikan oil drop experiments. So this one right here. I just wanted to focus on this for today. Okay. Now, when you were reading the Millikan oil drop experiment and the gold foil, you should have seen a picture that looks something like this. So what happened is with Rutherford, he was shooting some alpha particles. So here are the alpha particles, alpha. And what happened was the majority of them went through with some that were deflected quite severely, like this one right here. And so he predicted that there was something in the core that had a solid, that had a positive charge and took up the majority of the atom. And this was the discovery or the start of the idea of a nucleus. Okay, and that the nucleus, because it deflected the alpha particles, which were positive charges, the nucleus was a positive charge. The other thing that you probably talked about was the Millikan oil drop experiment. So what was the Millikan oil drop experiment? Was that it was used to determine the charge of a electron. So what Millikan did was he sprayed some oil droplets, and going through a hole, he was able to time how long it took an electron to drop from one plate to another. Now, if we increase the voltage of the negative charge, notice if we did the same experiment, notice it took a lot longer for the oil drop to drop. And so what happened is there must have been some repulsion between the negative plate and the oil drop that was done. If we were to decrease the voltage down here, what happened? You notice it was a lot faster. If we take a look here, and the reason being is because there must have been less repulsion coming from the negative plate. And so as a result, if there's less repulsion, the oil drop would drop faster. So that was the oil drop experiment. Now, as you were going through this as well, one thing about the atomic mass, one thing that you should have taken a note of with your atomic mass, all of this is considered the relative mass. Now, what do I mean by relative mass? It is not the mass of your brother, sister, mother, father, whatever. Get it? Ha ha. But relative mass was that it was a comparison of one mass to another. So when we look at our periodic table, you notice why is carbon a mass of 12? And let's say hydrogen is a mass of 1. So what an experimentation, and that goes a little bit beyond the scope of this course, was that one atom of carbon is 12 times heavier than one atom of hydrogen. So this is why carbon has a mass of 12, while hydrogen has a mass of 1. And so because it is the relative mass. And so in this case, nitrogen is a 14 because nitrogen, one atom of nitrogen, is 14 times heavier than an atom of hydrogen. Now, so this is what we talked about when you talk about atomic mass. It's all relative mass. So an easy way to think of it is this. So let's say we draw a picture of somebody. Okay, so let's say this is my daughter, Caitlin. Okay, I can't pick on anybody in the class because, I don't want to be mean to them. And so let's draw a picture of me, Mr. Chan. Okay, so let's draw a picture of me. There I am. I have my dad bod here, nice belly, whatever. Now, what do we mean by relative mass? Is let's say my daughter, I give her a mass of 1. It doesn't mean that she's 1 pound or 1 kilogram or whatever. We just give her a mass of 1. This is my reference point. Okay? Now, for me, because I'm twice her mass, I would be 2. And here is because I am, oopsie, 2 times her mass. And this is why I'm given the mass of 2, because I am double her weight. Okay, so this is what chemists have used in terms of the periodic table, in terms of the mass of an atom. So I know back in grade 10, most of you said, oh, atomic mass is protons plus neutrons. The question is, how did they get that? Was through this idea of relative mass. So how we taught you back in grade 10 and grade 9 and so on is actually backwards. They figured out the mass first and then worked their way backwards to figure out the number of protons and neutrons, etc. Now, the last thing that you should have been aware of in regards to the atomic mass is notice the atomic masses are not absolute numbers. You notice carbon here is 12.0107. And again, back in grade 10, they talked about the idea of isotopes. Okay, and how did they determine the mass of isotopes? Is through something called a mass spectrometer. So what a mass spectrometer does is that it shoots a sample through one end, and using a magnetic field, what happens is it deflects the individual particles in that particular sample. And depending on how massive the particles are, the least massive will get more deflected than the more massive ones. Okay, just like if I was running in a marathon or a sprint between myself and somebody who's really tiny, who's really fast, notice they will be able to change direction a lot quicker than myself, because since I have a larger mass, I have more momentum, it's harder for me to change directions. And what happens is, hopefully we scroll down here, what you get is you get some relative peaks. In terms of, in this case, you'll get a graph. And in this particular graph, you see that majority of the particles have a mass of 20. The rest of these, right here, these would be considered the isotopes. Okay, and this is how you're able to get the numbers. If you look at this particular question, 90.9%, and so on and so on. Okay? And then using those numbers, you are then able to do the calculations where you multiply the mass times the relative abundance and so on. Okay, so this is a few things I wanted to touch upon in regards to this particular section of questions. So you should know what was going on with the gold foil and Millikan oil drop experiments. You should know how a mass spectrometer works and how you are to read the graph that you get from it and how you're able to calculate the atomic mass. All right, so that is the video to sort of summarize what you should have learned from this atomic theory introduction. Next video we'll learn is we'll move on to grade 11 material. Most of this stuff that you did should be grade 10 introduction. All right, thanks a lot. Hope you folks have a good day and talk to you soon.